Alright guys, as was stated earlier, we said that molecular orbital is formed as a result of combination of atomic orbitals. Alright, so we are trying to restate it here again. Each time we combine two atomic orbitals, we'll have two molecular orbitals. And these two molecular orbitals are namely the bonding molecular orbitals and the anti-bonding molecular orbitals. Very quickly, you just have to know that the anti-bonding molecular orbitals are of higher energy than the bonding molecular orbitals. Alright? Now, remember, I told us earlier on that when we combine atomic orbitals, we form molecular orbitals. But the question you should ask yourself is that how many types of orbital do we have? We have so many types of orbitals. Alright, we have the s orbital, we have the p, we have the d, and we have the f. But we're just going to focus majorly on two orbitals. That's the s and the p. Alright, so I would like to take it one after the other so that you really understand the build-up of how these molecular orbitals are being written before we get down to the final stage. Now, molecular orbital, the first one, we're going to be looking at molecular orbital involving the s orbital. That is when we combine s orbital, what we're going to obtain. Now, it will interest you to know that s orbitals usually form a sigma bond. We're going to explain what sigma bond means at a later time or a later stage in this course for the course of this video. Now, s orbital usually form a sigma bond. We also have pi bond. S orbital does not form a pi bond. S orbitals form specifically sigma bonds. So we said, therefore, when writing molecular orbitals obtained by combining s orbital, we'll use the sigma bond symbol. This is a sigma bond symbol, and this is a pi bond symbol. So anytime you are combining atomic orbital of s, this is the symbol we are going to use. Please take note of this. Now, we said when you bring two atomic orbitals together, you form molecular orbital. So we are just trying to represent it here. Atomic orbital plus atomic orbital giving us molecular orbital. Now the first orbital we are going to look at is the s orbital. But notice in an atom, orbital is not just standing alone. Orbital is always attached to energy level. Alright? So that is why s can be 1s, 2s, and 3s. But please note, in terms of the energy level, we are not going to exceed 2. And in terms of the orbitals, we are not going to exceed p. So you should just know that in this MOT, for this course and for this level, the highest energy level you're going to make use of is energy level 2. And the highest orbital you're going to make use of is p orbital. So when you combine 1s and 1s, this is two atomic orbitals coming together. I'm going to have two molecular orbitals. The bonding 1s and the anti-bonding 1s. Remember we said earlier that for every time we combine two atomic orbitals, we always give rise to two molecular orbitals. This is what we have here. When I combine 1s and 1s, I'll have molecular orbital 2. And these two molecular orbitals will be the bonding and the anti-bonding. The bonding is the one without the asterisk, and the anti-bonding is the one with the asterisk. Remember I told us that whenever we are combining s forms sigma bond, so we're going to always use this symbol to actually represent for s. Since the energy level here is 1, that is why we are attaching this 1 here. So when you go ahead to combine 2s and 2s, you're still going to have the same thing very similar to this first one. Bonding 2s and anti-bonding 2s. Bonding because this guy does not have an asterisk, anti-bonding because this guy have an asterisk. Anytime you're writing molecular orbital, the one that has the asterisk is the anti-bonding, and the one that don't have the asterisk is the bonding. Remember, molecular orbital is always written in terms of the bonding and the anti-bonding. Alright, so this is this for the s. Alright, remember I said earlier on that in terms of the energy level, you cannot combine energy level 3 in this level. That does not mean it's not possible. That is advanced. But for this level, for this undergraduate level, the highest energy level you're going to see is going to be 2. You're going to see 1, and 2. In terms of orbital, the highest orbital you're going to combine is p. In other words, you're going to combine s and p. You cannot exceed p. Alright? At this level, this is where you're going to stop. Right? But for now, I just want us to understand that of the s before we proceed to p. Alright? So looking at here, I recap, s orbitals form sigma bond only. In other words, whenever you're writing molecular orbital involving the S, you use the sigma bond symbol, which is this. When you combine one S of this atom and one S of this atom, you're going to have two molecular orbitals, the bonding and the anti-bonding. But since it was S that was combined, I will use a sigma bond symbol because S orbital is going to form a sigma bond. Now, since the orbital was on the first energy level, that is 1, that's why I'm having 1 here. If it is on the 2, I will have 2. So please take a look at this, try to absorb it. I'm trying to give us a foundation. I don't just want to jump into writing the final state for us.